In this question, we were told that you start from a certain point and you travel 18 meters to the west and 25 meters to the north. Now, you might see that these compass bearings over here look awfully like a Cartesian plane, right? This being the x-axis, this being the y-axis. So, if we want to find out how far we are away from our original starting point, then it's actually quite easy to do that. Our position, where we've ended up, is negative 18 I hat, it's 18 to the left, plus 25 j hat, that's 25 to the north. Now, what we're being asked for is how far we are away from where we started from, that's r, and what is the internal angle over here, our angle of orientation. Now, we more commonly in this class use this as our angle of orientation. So we will solve for this theta first, and then we'll solve for what that internal angle is. So, as you've probably guessed, this entire question simply boils down to taking a vector that is in Cartesian and turning it into a vector in polar. So let's try it out. The distance in polar, or the size of the vector, is given to us by Pythagorean theorem. Negative 18 squared plus 25 squared, and take the square root of the whole thing. So, let's solve this out. Negative 18 squared plus 25 squared gives us 949. The square root of that answer is 30.81. Now, what about the angle theta? Theta is given to us by the arctangent of y over x. Arctangent of y is 25 over x, negative 18, which works out to arctangent of 25 divided by negative 18, negative 54.25. Now, you'll notice the problem. Negative 54.25 points off in this direction, below the x-axis, below east. So we have to remember our rule. Any vector that points in the second or third quadrants has to have 180 added to this theta that you get from this equation. So add 180 and we get 125.75, and this is the value of theta. So if this angle over here, theta, is 125.75 degrees, then this interior angle over here, let's call this angle, I don't know, let's call it beta, for example. Beta is going to be equal to 180 degrees minus theta, which we said was 125.75, which will give us 54.25 degrees. So this is a question where we were given effectively a vector in Cartesian coordinates, negative 18i hat plus 25j hat, and we had to convert it into polar coordinates. So in polar form, we would say that this vector is 30.81 meters at an angle of 125.75 degrees. This would be the representation of this vector in polar. In this question, we are told that a plane flies a distance of 40 kilometers at an orientation of 60 degrees, followed by 30 kilometers at an orientation of 15 degrees, and we want to find what its final location is. That's the same thing as asking, what is the resultant of these two vectors when you add them together? That's easy enough to do. Let's start by taking these two vectors, which are currently given in polar notation, and convert them into Cartesian. So in Cartesian, we have to figure out x, which is r cos theta, and y, which is r sine theta. Now, the first vector had a size of 40, and it was oriented at 60 degrees. Whip out your handy-dandy calculator and figure out what 40 cos 60 is. It's 20. So x for this first vector is 20. What about y? Well, y is figured out as the size of the first vector times the sine of the angle, which is 34.64. So 20i hat plus 34.64 j hat would be the Cartesian notation for this first vector, 40, 60 degrees. Now for the second vector. That's 30, 15 degrees. Again, find x. 30 cos 15, that's 28.98. And 30 sine 15, 7.76. So, the total of these two vectors, the resultant vector, is found by just adding these together. 20 plus 28.98 will give you 48.98. And 34.64 plus 7.76 will give you 42.40. So this resultant vector has a size of 48.98 I hat plus 42.40 j hat. But maybe we want to convert it back into polar. Let's go ahead and do that. The size of this resultant vector is given by the x component squared plus the y component squared, and take the square root of the sum. It's just Pythagorean theorem. So 48.98 squared plus 42.4 squared gives us 4,196, and take the square root of that, 64.78. Theta is the arctangent of 42.4, that's y, divided by 48.98, that's x, which gives us 42.4 divided by 48.98, 40.88 degrees. And since this point's in the first quadrant, we don't need to apply any corrections. So this resultant vector is described as 64.78 at an angle of 40.88 degrees. And that is also the location of the plane at the end of the story once it has completed the two legs. In this question, we were asked to find the final position of a male man after he has traveled on a journey of 4 legs. The first leg was to travel a distance of 40 miles north. Now, northwards in our coordinate system over here points in the direction of 90 degrees. So this is the first leg of the journey. The second leg of the journey was 20 west. And if east is 0 degrees, west of course would be 180 degrees. The third leg is 60 degrees northeast. So if east is 0 and north is 90, northeast is exactly halfway between the two, which is 45. And fourth was 50 north. Again, north of course was 90. Now, because I am such a stickler for pictures, I'm going to draw this. You don't have to sit for the whole thing. Now, if we want to find this person's total motion, where they have ended up relative to where they started from, we simply find out what vector starts from the starting point of the first vector and ends at the terminal point of the second vector. So we want to find this. That's easy enough to do. All we have to do is add together all of these different vectors. But of course, we can't do that in polar. We have to turn them into Cartesian first. That means that we need to find x, which is r cos theta for each one, and y, which is r sine theta for each one. Fortunately, many of these are so simple that I don't need to use a calculator. For 90 degrees, the cosine is 0, and for 90 degrees the sine is 1, so 40 times the sine of 1 will give me 40. What about for 120 degrees? The cosine of 120 degrees is -1, so 20 times -1 is going to give me -20. And 20 times the sine of 180 degrees, well, the sine of 180 degrees is 0. So 60, 45 degrees. This is one where you actually do need a calculator. (60) times the cosine of 45 is 42.43. And 60 sine of 45 is the same thing. Finally, 50 at an angle of 90 degrees. Cosine of 90 is 0. Sine of 90 is 1, so we just add 50 over here. And now we add all of these together. -20 plus 42.43, that'll give us 22.43. So that's our I hat. And 40 plus 42 plus 50, that'll give us 90 plus 42, which is 132.43 J hat. So this is our overall position of our mailman. 22.43 I hat, that is 22 kilometers east of where he started from, plus 132.43 J hat, that's 130 kilometers north of where he started from. And if we want, we can turn this into polar. We use R is equal to 22.43, that's the x component squared, plus the y component squared, and then take the square root. It's just Pythagorean theorem. So that will give us 22.43 squared plus 132.43 also squared, and then you take the square root of the result. 134.32. And then you have theta. Theta equals the arctangent of y over x. So y is 132.43 and x is 22.43. So let's work this out. Arctangent of 132.43 divided by 22.43 gives us 80.37 degrees. So this is the position of the milkman. The milkman, or the mailman rather, is 134.32 kilometers from where he started from at a compass bearing of 80.37 degrees. And if he were to come home as the crow flies from this point, he could do so by traveling 134.32 kilometers, but in the opposite direction, which would be 80.37 plus 180 degrees.